So these are these ZFS options right here. And here's snap directory, ACL inherit, create TX tags, can mount, Xadder copies. This right here is how many copies of the data. So if you have 2 copies here, obviously you're going to be taking up twice as much space. Now you're asking yourself, why would you want to do that? So if any data gets corrupted on one copy, it will automatically reach over the second copy during scrubs or whatever, and it makes your data more redundant. Now if you're doing it with one drive, it's gonna slow it down, even if it's an SSD, unless you have something like a really fast NVMe and stuff like that, then not so much. Now if you go down here to volume mode, this is for your Z volumes that you can create. I do full, that's what I recommend. I don't think it's like that by default, you might want to check. File snapshot count, that's how many snapshots you have. Snapshot limit, I got mine at 500. Now you can raise or lower the limit to save space if you wish to keep your drive from filling up. This is your ACL type. That's like access control. I got mine set for NFS v4. That way it gives extra NFS attributes, I think, on like the metadata and stuff like that. Special small blocks. This is in case if you are running a specific ZFS pool. So if I do ZFS or Z pool status like this, so you can see I have 1, 2, 3. I have 3 mirror sets and 1 device just sitting by its lonesome self. This one right here has a few checksum errors. I'm not really worried about that. These are my 2 special mirrors. So anything that is below 512K block size, what's going to happen is anything this and below is going to go to these drives. And that's so the drives operate at a faster. That's so that anything below that gets rid of the NVMEs, so that the NVMEs, because they're not physical spinning rust, they're able to switch back and forth really quickly between small files, so the I/O is really high. Which means that if you have tons of little tiny bitty small files, the NVMEs work great on those. Right here is the cache. So all 4 NVMEs have 1 partition each for the caching, and these are 2 sets of mirrors for the logs. And this is the special. So your logs are essentially like a write cache. From what I see, they're not super important, but well, from what I've seen, I've only seen like a little bit of performance increase from the logs. Special, this works great. I definitely recommend this. The logs right here, you get a little performance, but not really much. Now, it's supposed to be like essentially a write cache, but it doesn't work kind of like a full write cache. It's really hard to explain. So if you look up the data usage, it's essentially whenever you write data, what happens is it writes the data directly onto the drive, unless you're in like, async, which then it's going to try to write as fast as it can, but some of it gets stuck in RAM. But if you have like a power outage or anything, then you could corrupt some of that data. So what this does is it allows that some of that data to be written to the drives first. If you have something like really fast, like I wouldn't recommend using this unless you have something fast like an Intel Optane or any other specific drive like that that's built specifically for speed and I/O. Anyway, now since I've gotten off that, let's go back to the ZFS options here. Here's your overlay. Like if you're using like something like Docker or anything like that, that's going to be your overlay right there. So that's going to be your overlay set. If you're using something like Docker, like your file system overlay, so you can overlay specific file systems. And Linux also has a built-in kernel option for it. And by the way, if you want your kernel to be faster, I recommend all the modules be built directly into the kernel. There's your real A time right there. So real A time is your access time. So let's say you have when a file was accessed. Let's say you accessed a file at 310, right? And you made a modification to it. So this is going to be the update frequency of when those files were touched. Now this can affect I/O a decent amount because every time you write to a file, it's going to update it. So if you don't have like real A time on, what's happening is maybe you make a write at the file at 311, but the modification time doesn't maybe change until maybe like let's say 315 or something like that. So it's going to be off. Your modification time of files and access times of files will be off slightly. But if you use real A time, it's going to be checking all the files in the OS more and making sure that time is accurate or as close to accurate as possible. Root context, I actually don't know what that is. If somebody knows, tell me because I don't know. Same with FS, file system context, and def context and context. Now we have snap dev, which is your snap device, which means hidden. There's your snapshot count, which means how many snapshots you actually have taken or currently have. And I believe, let's see, well, I would check that now, but I can't. File system limit, logical reference, 564 gigabytes, written 207 megabytes, reference compressed ratio 1.34. Denote size 16K. Yeah, 16K denote size. So this is gonna make your metadata size go up, but it keeps more helpful data and stuff on the files, from what I understand. But having this be higher can affect how grub boots, from my understanding. So personally, I boot directly from like a USB or another drive. And besides this setup, what I like to do is I like to make sure that I don't even like to do a partition table on the ZFS drives. I like to just go ZFS, create right over the drive without a partition. And one of the reasons is because it does not rely on the GPT partition scheme that's kind of on the underlay. Now, if that gets damaged a little bit, it usually doesn't matter, but that way it's not even relying on that, just straight ZFS. So if you do that, you're not going to want to partition your drive first before you put ZFS on it. You're going to want to just slam ZFS on it right away directly. Sync, this is your sync method with your files and stuff. Like I said, asynchronous is the one where you risk data corruption if you have an incorrect power off or you power off too quickly or something like that. Now, from my experience, yeah, we'll just keep it like that. I'm not going to go into that anymore because I don't want to tell you anything wrong. Dedupe off. If you have data deduplication on, you can have 10 files that are the exact same, and as long as they match the exact same byte per byte, what's going to happen is instead of having those 10 files take up 10 times the space, you're just going to be taking up one of those file spaces, and then there's going to be kind of like a hidden file system link to the same file for the rest of those 10 other files that's on the operating system. Object set ID, I have no clue what that is. Log BIOS. Throughput. Log BIOS equals throughput. Used by ref reservation. I don't know what that is. Used by children. That's your children datasets. Used by datasets. Used by snapshots. There's your secondary primary cache. I recommend leaving both of these on all. Rest reservation 10 gigs. I can't remember exactly what this was again. Let's look that up here. Now, okay. Let's see right here. What is the definition of this again? The reference, quote, and reservation properties are used to manage file system space without accounting for disk space. consumed by descendants. I'm guessing that means snapshot children and stuff like that. Luckily, I only have one kid, so okay. In this Solaris Suite, you can set a user or a group quota on the amount of disk space consumed by files that are owned by a particular user or group. The user and group quota properties can be set on a volume, on a file system version 4, or on a pullable 4 version 15. The reference code and reservation properties are appropriate for managing disks consumed by data sets. Okay, setting the reference code for higher has no effect. Blah blah blah. So I can tell you exactly what that means. But if you have a reservation, that's how much data is going to be guaranteed. Yeah, like this one right here, I know what this is. Record size, that's going to be your record size. Now this one is important. Let me explain about record size. Record size is pretty much the most important thing when it comes to managing your data sets and stuff. So, like let's say if you're working with smaller files, the smaller your record size is, the more efficient your drives are going to work on smaller files. The bigger the record size, the more efficient your drives are going to work on larger size files. With NVMe's, I recommend doing a 16K record size. The reason why is because you're not overloading on I/O. So if you go too slow on the record size, what's gonna happen is it's gonna cause your drive to pretty much overload itself when it's processing like I don't know, small files, and then you're gonna see your CPU usage bounce because you're doing like an I/O. You're essentially flooding it with I/Os. Now, some of the newer NVMe's and stuff, they'll be able to handle a lot smaller block size without being bogged down or slowing your system down. So the newer the NVMe, the better, because it's gonna be faster and it's gonna have more I/Os. And if it has more I/Os, you can go ahead and get this a lot lower. What I mean by a lot lower is like as low as 1K if you forked out, you know, a kidney for an NVMe. Reservation right here is 10 gigs. Quota is none. Mounted is yes, that just means it mounted. That's the compression ratio of the data, which means it has 0.39x compression, which means 0.39 or 39% of the data is what do you say? I guess you'd say compressed. Referenced, you have that much data referenced. Not exactly sure what that means, but I know your reservation right here, this is going to guarantee you have this much space left, which in fact I should change mine. So I'm going to go ahead and change mine now. I want mine to be at least 100 gigs. So let's see, I want to change it, right? Copy this, go down to here, ZFS, set duration equals 100G, and then rpool. Like that. Now I've changed it. Now if I go back and do this, oops, like that, we should see, yeah, 100 gig right there. So it changed. So this is your compression. LZ4 is generally the best. Now when you add your compression, in with how your block size works, keep in mind to use a very, very small amount of CPU to do some of that compression, but LZ4 is so fast and so efficient that I'd never take this off. I'd pretty much always keep it on. So keep in mind, if you have 16K here, your record size is actually going to be operating actually a little smaller than this with LZ4. Now, the larger the record size, the more effective the compression. The lower the record size, the less effective the compression. In my opinion, this is the best all around to keep with a decent pair of NVMe's. Would be 16K and LZ4 for all your data sets. Now you can put larger files in specific data sets and then change that record size for that data set. And if you want to get crazy with it, it's good. Also, another thing about small record size is if you're doing a lot of coding and you're searching for like strings of data and stuff inside text files, if you have a really small record size, you're going to be able to do grep and set and search through text files for phone numbers and stuff like that a lot faster. So it's going to work a lot faster when it comes to searching for those little bitty bytes of data if you have your record size really low. And I mean like a lot lower than 16K. Problem is, you can bog the crap out of your system. So, if you have NVMEs that are worth a kidney, go ahead and put this baby low. Anyway, what I can tell you, that's about it. I went over all the ZFS options. I hope I did it correctly for y'all and sounded somewhat professional. Anyway, if you liked the video, like and subscribe. Hopefully I gave y'all some helpful information. Buy me a cup of coffee. Send me a donation. Or if you're trying to divorce your ex-wife, you can send her over this way. Alright, so I'm out. Thanks again.